Half the tests in statistics assume your data is roughly normal. The t-test, ANOVA, regression. So, before you trust them, it pays to ask, is this distribution actually normal? The QQ plot answers that by I. QQ stands for Quantile-Quantile. The plot sorts your data and asks, for each point, where it would land if the data really were normal. Your actual value goes across the bottom. That predicted position goes up the side. One rule does all the work. If the points fall on a straight line, your data is normal. Here's wafer thickness. Points hugging the line, close to normal. Now watch what happens with a skewed variable. The line bends. A curve means skew. An S-shape means the tails are off, heavy or light. Points stranded at the ends are outliers. Each kind of departure has its own signature. Real samples always wobble a little, though, even when they're normal. So, turn on confidence bands. Points inside the envelope are consistent with normality. Points that stray outside are the ones to worry about. And it's not just for the bell curve. Pick a different reference distribution, and the same straight line test applies. When you need a number for a report, Stratum runs 3 normality tests: Anderson-Darling, Kolmogorov, Smirnov, and chi-square. Read the p-value like this. Small below 0.05 is evidence the data is not normal. Large means it's fine to proceed. And if it fails, transform the variable, use a rank-based method, or lean on a large sample. The plot tells you which path to take. Next, dot and strip plots and the Pareto chart for finding the vital few.